Welcome to Stat Speaks, organized by the University of the Philippines School of Statistics. Ako po si Xavier Javinas Bilon, faculty po sa school, and I will be moderating today's lectures. Sumapalad po tayo today to be joined by two of our professorial chairs in statistics who will share their work on relevant and contemporary topics in the field. So bago ko po tawagin yung una nating speaker for today, may ilang paalaala lamang po ako sa ating mga participants. So first po, we request everyone to reserve their questions for the Q&A forum at the end of each presentation. So sa dulo po ng presentation, we'll have the time for your questions po at para masagot din po ito ng ating speakers. The audience are also enjoined to use the raise hand feature of Zoom to facilitate the Q&A forum in an orderly manner. Pwede nyo rin pong gamitin yung ating chat feature. Kung meron po kayong tanong, pwede nyo pong isend to everyone or pwede nyo pong isend privately sa akin. Whether you are asking questions po live or relaying it via the chat box, we request you po to use the following format when asking questions. So sana po sabihin niyo po muna yung inyong pangalan, ang inyong university or institution or agency bago po ang inyong mga tanong. Okay? So our first speaker is Prof. Martin Augustine Borlongan, who will talk about testing for non-trivial principal components in the presence of outliers. Prof. Martin is this year's awardee of the Robert Coyuito Professorial Chair in Statistics, and he is an assistant professor of the School of Statistics, University of the Philippines, Diliman. He obtained his Master of Science in Statistics degree from the same institution, and his research interests are in the fields of non-parametric statistics, robust statistics, categorical data analysis, and computational statistics. So let's all welcome po Prof. Martin with our virtual reacts. Magandang hapon po, Prof. Martin.
Hapon po sa inyong lahat. Maraming salamat, Sir Xavier, for the introduction. I'm very glad na makasama po kayo this afternoon, and I hope lahat naman po tayo ay safe sa kanilang bahay. We know na merong bagyo na paparating, no? So I hope everyone is safe. So, ayan, maraming salamat po for attending this Professorial Chair Lecture. So allow me to share my screen so that I can start presenting my simple exploratory study. So as Sir Xavier mentioned earlier, so my exploratory study is about testing for non-trivial principal components in the presence of outliers. So this is actually a continuation or an extension of my previous work, which I also presented last year. This time, I used yung results coming from that study and extend it to an application that is relevant when we want to build indices coming from a set of variables. Okay, and obviously that will be by extracting principal components. Okay, so this is not just a test for non-trivial principal components. A lot of researchers have already studied yung tungkol doon. What we want now is to incorporate the presence of outliers, or to be specific, influential observations that may have an effect on the resulting principal components. So to give you an overview of my presentation, so we will first talk about key concepts, rationale and motivation why I did this research, and yung objective nung ating ginawang study. So that will be for the introduction. For the methodology, I will be presenting you kung ano yung mga approaches na pinagsama-sama natin to come up with this new proposed na method. And then I will be presenting yung simulation studies that I did to check how my proposed method will perform. Okay, so obviously since simulated ito, synthetic yung data natin. So well-behaving pa sila, no? Pero let's check kung well-behaving yung data natin, how will this proposed method perform? And then I will be presenting sort of an initial set of results. Marami na akong na-discover dito, but I still want to do additional runs to confirm some hypotheses that I came up with based on the results. So for the introduction, key concepts, regarding outlier detection, this is a relatively long set of slides and limited yung number of minutes that I'm allowed to take, no? So I will not be discussing in detail yung bawat isang bullet, but the idea behind outlier detection is that it's a known fact, but it's quite hard to detect or to identify an umbrella procedure that will allow us to do an automated way of checking outliers. Wala yung problema if we are dealing with, let's say, dalawang variables, tatlong variables, but in the context of PCA, where you will be probably working with more than 10 variables, no? Mahirap gawin yung pairwise na check. And at the same time, outliers may not appear when we look at pairwise associations, or kung 10 variable yan, no? More than 2 dimension, it will be hard for us to visually inspect kung ano tong mga outliers na to. So there are a lot of studies that deals with outlier detection, but the idea is if you can find an outlier detection procedure that will be at a certain degree successful in detecting these outliers, no? Ay napakalaking tulong nito, especially in how we clean our data. Okay? So the most popular way of identifying outliers is in the multivariate setting is by using the Mahalanobis distances. So I was not able to present the formula, but it's a function of the sample mean vector and the sample covariance matrix. Now, by definition, no, when we use mean in a univariate case, ang laging reklamo with the mean is that it's greatly affected by outliers. So this Mahalanobis distance, which is a way of identifying outliers, may be affected by outliers. Okay, so medyo ironic, but especially if you're dealing with relatively many outliers in your data set, okay, na kung saan hindi naman daling makita itong mga outliers na to if we base our decision on the Mahalanobis distances. Okay, so this is mainly because of what we call the masking effect. So ang nangyayari is if you're just a single outlier in your data set, baka madali kang makita. But if there are more than one outliers in your dataset, those outliers may have so much effect on the Mahalanobis distances na seemingly hindi na sila ganong kadaling makita. Okay? So depende rin po yan sa type ng outlier na meron tayo. There will be outliers na kahit medyo marami sila ay nakikita pa rin ng Mahalanobis distance. Okay, so this masking was defined by Bendre and Kale as the loss in power of a test for outliers due to the presence of more than the anticipated number of outlying observations. And this poses a problem to us because it will be quite hard for us to anticipate kung ilan ba yung outlying observations, because in the first place, we don't know kung meron bang outlying observation or wala dun sa ating dataset. Okay, so there are certain measures that you can do to solve the masking effect, such as using robust distance measures. So you can robustify yung Mahalanobis distances by replacing the sample mean vector and the sample covariance matrix with their robust counterparts. Okay, so the problem with also finding outliers is that you may be an outlier in terms of distance, gaano ka kalayo dun sa ibang set of observations. But when you perform your analysis, ay hindi ka naman pala outlier in the sense that the parameter estimates are still virtually unchanged, no? Regardless kung nandun si outlier or wala. So for example, if you're doing a simple linear regression or if you're fitting a simple linear regression model, pwedeng by distance ang layo mo sa observation, but based on the linear pattern that you're trying to identify, okay, ay hindi ka naman pala nalalayo. And therefore, we need to be able to separate outliers, okay, from influential observations that may change the results of our analysis. So in the context of principal components analysis, so the alternative is we monitor the sum of squares of changes in the individual elements of an eigenvector as a way to measure the influence of an observation. And this is one of the key ingredients dun sa ginagamit ko na influence measure. Okay? But the problem with this one is that it's a leave one out strategy. Hindi natin na-solve yung masking effect in the sense that if you remove one outlier from your dataset and there are 20 more remaining in your dataset, ay hindi natin ganun nakikita yung effect ng pagtanggal ng isang observation. So again, there are ways na halimbawa, instead of leave one out, merong 10-10 yung pagtanggal. Pero again, the problem with that is how will you identify kung ilan yung tatanggalin mo to check their effect. Okay? So the proposed influence measure that I'm using for outlier detection is based on this alternative by Joliffe. Okay? But I am trying to solve the masking effect by utilizing another algorithm, which is the forward search algorithm. So the idea behind the forward search algorithm is you try to come up with a clean initial data of size small m, which is obviously less than n. Okay? And n is the original number of observations in your dataset. So itong clean initial dataset, pinipili yan based on a certain criteria. And we are going to assume na itong clean initial dataset na to ay wala talagang outlier dyan. Kumbaga, pure yung dataset na yon. Now, obviously, anong mangyayari dun sa n-m na observations na hindi naisama dun sa initial data? So what will happen, and as the name implies, forward search, magpo-progress yung ating forward search by one, including those who were initially omitted from the initial dataset. So isa-isa silang papasok. Pero the idea behind the entry is hindi pwedeng basta-basta pumasok. You should satisfy a particular criteria for you to be able to enter the clean dataset. So kumbaga, no, itong clean dataset natin ay mga assure tayo na walang sakit. Okay? At hinahanap natin or tinatry natin i-prevent na ang isang data na may sakit ay makapasok dun sa clean dataset natin by applying sort of a test. Okay? So for each entry of an observation, i-monitor lang natin what happens to the parameter estimates. That's the main idea behind the forward search. Although you might not heard of forward search, matagal na po yung nagamit. But the first few iterations of the forward search ay masasabi natin na manual ginagawa. At if there was a cutoff na ginawa or criteria na na-apply, it imposes a set of distributional assumptions dun sa ating data. At ang common na distributional assumption for those cutoffs ay multivariate normality, which we know na hindi naman ganun talaga ka-common in reality. Okay? So, yung manual way of monitoring or of determining kailan hihinto si forward search is by looking at a forward plot. Anong nangyayari doon sa parameter estimates habang nagdadagdag ka ng observation. So you're not really testing before entering. You are checking by allowing this the observations outside of the clean data to enter the clean data at titignan mo kung anong mangyayari. Okay? At kapag na-identify mo na, oh, biglang nagbago yung parameter estimates ko, ang laki ng jump, then makikita natin yun sa plot as a dip, biglang babagsak yung value of the parameter estimates or biglang tataas. Okay? Now, personally, I don't want that approach because unang-una, it's not automated and it's subjective. Okay, ganun ba kataas yung mataas para masabi na, oh, I should stop the forward search at tanggalin ko na lahat ng data after this point. Okay? So, I want a procedure na hindi talaga i-allow na makapasok if there is evidence na this entry will affect the parameter estimates. Okay? And that will be the forward search algorithm. Now, PCA, it's mostly viewed and utilized as a descriptive tool. Okay? Although, if you will be able to find a reference, makikita nyo na meron palang set of distributional assumptions that you can impose so that itong eigenvalue, eigenvector that we can derive ay meron tayong sampling distribution. Pero most of the time, no, hindi natin siya ina-apply. Okay? So in fact, you can apply PCA for as long as meron kang, let's say, hindi kailangan masatisfy yung multivariate normality assumption for you to be able to derive your eigenvalue and eigenvector. For as long as you have a symmetric matrix na you can work on. So it's commonly used in index building due to its dimension reduction capability. So these derived variables, which linear function of your original variable, is called principal components. You might have heard of this PCA as one way to solve multicollinearity when you're doing linear regression modeling. So Eisenman pointed out that PCA can be used in detecting outliers. No? So parang a double-edged sword itong PCA. For me, it will allow me to detect outliers. Okay? At in the end, it will allow me to do a PCA na unaffected by outliers. So since PCA is mainly used as a dimension reduction algorithm, one of the major decision points in using it is the number of PCs to retain. Okay, so the usual objective is from P variables, sana isang PC lang yung ma-retain. Okay, or dalawa. Okay, kaya siya nagiging dimension reduction algorithm. So Joliffe and Kadima in their study illustrated the use of PCA in profiling fossil teeth based on 9 measurements. So the first two components already account for roughly 95% of the original variation in the data. And itong dalawang principal components na to allow them to identify possible common species from the sample. And I think it will be a lot easier, or it was a lot easier for them to do this because they're not working on the original 9 measurements, but on a composite variable, which is a function of the original 9 measurements. So in evolutionary biology, common pa rin ginagamit itong PCA, no? So if you have a large number of measurements of various variables that may be used to understand ecological patterns, one of the main objectives is i-limit or pakontiin itong set of variables na ito. So if you have a target variable, another target variable, and then you want to explore no, kung ano yung relationship nitong original set of variables to that one, it will be time consuming, especially if pairwise mo lang titignan yung kanilang relationship, and at the same time, it will not account for the interdependencies of these variables. So, for example, 4 morphological measurements may be reduced to one principal component representing size. Okay, and it's easier for you to work with a single variable and correlate it to to an ecological variable of interest. So this becomes a problem of pairwise association instead of multiple pairwise associations between the 4 original variables and the ecological variable. So for the rationale and motivation, so I'm trying to explore the outlier detection capability of my previous proposed method. Okay, this method was also used by my previous publication, no, wherein itong influence measure na to was used to come up with robust simultaneous confidence intervals of the principal component loadings. Okay, so coming from that one and the result also from my study last year. So ang result kasi last year, no, is that even though there are outliers na napapasama pa rin dun sa pool of clean data, and at the same time there are clean data na napapasama dun sa set of outliers. So my hypothesis, and the reason why I try to do this is yung results of PCA using this supposedly clean subset is already quite stable enough nung huminto yung forward search. So I'm assuming that the result from the clean data from this proposed method ay okay na, stable na, and it reflects kung ano talaga yung meron dun sa data, dun sa clean data na meron tayo. Okay. Yeah, so I'm skipping some parts. So PCA is known to be affected by outliers. I've already mentioned that earlier, no? And given that it has an effect on the results of PCA, and therefore, one of the results kasi of PCA ay yung pipili ka ng principal components to retain for your subsequent analysis. And many of the heuristic approaches in determining kung ano yung i-retain mo na PC is based on the eigenvalue. So kung affected sa eigenvalue ng outliers, then affected yung choice mo ng outliers. So another side of this is the researches, applied researches using PCA, they rely too much on heuristic or yung practical way of determining kung ilang PCs yung i-retain. And by retaining, ibig sabihin, those PCs are non-trivial and they are interpretable. Okay? So this also are known to overestimate the number of non-trivial PCs. So may illustrate natin yan once we go to the results. So isa lang po yung objective ng aking study. It's to come up with a method that will be able to determine or suggest the number of non-trivial PCs to retain using bootstrap-based methods while reducing the effect of outlying observations. Okay, so for the methodology, it's the usual data setup wherein the number of observations is more than the number of variables. Okay, for the test data, in order for me to come up with data na i-apply yung ating proposed methodology, I use the correlation matrix approach, and para makapag-generate ako ng correlated variables, I use the Cholesky decomposition. So from an initially uncorrelated set of variables, ay pwede natin gamitin si Cholesky decomposition so that the structure, yung correlation structure na gusto nating makita, ay pwede nating ma-generate from those uncorrelated variables. So we incorporate outliers in the data set, although there are scenarios na pwedeng walang outlier para ma-check lang natin how our proposed method will perform. Okay? So for the actual selection, this is quite detailed in terms of the forward search algorithm. But since my main focus will be on determining the number of PCs, so siguro interested participants may just email or consult with me kung ano yung main approach in the actual forward search algorithm. So I'm just applying this new influence measure, which just monitors anong nangyayari if we add an observation to the currently existing na parameter estimates. And this alpha hat here is the estimate of the loadings. Okay, so isang eigenvector yung isang alpha. Okay. Now, for the bootstrap-based CI, so at this point, we are ensured that the forward search algorithm already picked yung clean dataset for us. So meron na tayo dito isang dataset na ina-assume natin na walang outliers na naman. Okay? Or kung meron mang outlier na naman, walang influential na observations doon. So my approach in determining kung ilan yung non-trivial PC is through bootstrap. Okay? So I'm building bootstrap-based CIs, 1 minus alpha 100% CIs. Okay? Approach 1, a PC will be deemed non-trivial if the CI of its eigenvalue does not include 1. Okay? Yung 1 kasi, if you're working with a correlation matrix, okay, yun yung average eigenvalue kapag equally split siya among all p variables. So kapag correlation matrix kasi, the sum of the eigenvalues will be equal to the number of PCs. Number of variables. And then the other approach, a PC will be deemed non-trivial if the CI of at least 2 elements of its corresponding eigenvector does not include 0. Okay? So approach 1, walang magiging masyadong problem dyan. Even if you do bootstrapping, you will have a difficulty in terms of the second approach because of the arbitrary axis reflection. So when you say arbitrary, kapag nag-bootstrap ka kasi, no, let's say you do bootstrap sampling, pwedeng yung first eigenvector mo, yung malalaking value nila ay positive, pero nung nag-bootstrap ka pa rin, pwedeng negative yung value nun. Pero it really is not a difference. It's just the way this software, okay, assigned or kasi pag multiply mo siya ng positive, ganun pa rin, no? Inaano mo lang, nire-reflect mo lang or minumove mo lang yung axis. Okay? So that is one of the challenges na encounter ko when I did the bootstrap. So for the simulation study, to explore if we can identify the number of non-trivial PCs. Okay, ito yung mga sinet natin na or consider natin in our simulation scenario. Number of observations, we have 100 and 300. In the usual ecological setting, konti lang kasi nakukuha na sample, no? So we want to test yung performance ng ating selection procedure na relatively konti yung ating maliit yung sample size natin. I also considered the correlation structure. That is the group, ilan yung correlated na variables, ilang group, at gaano kalakas yung kanilang correlation. And then I also checked whether an adjustment to the confidence interval must be done. The adjustment is a sort of Bonferroni type adjustment, similar to what we do in pairwise comparisons after the analysis of variance. So ano yung mga magkakalaban? Ang pinaka-common kasi, and this is also the reason why I picked this, yung Kaiser-Gottman rule. Ito yung alam natin na you retain PCs with eigenvalue greater than 1. So we will call that KG. And then yung bootstrap eigenvalue and bootstrap PC loadings, we will call that boot-eigenvalue and boot-eigenvectors. Now, the first runs I did, I noticed that for the bootstrap PC loadings, which is yung approach number 2, marami ako na-observe na 9 yung nire-retain niya na PC. Okay? And I only utilized 10 variables in these runs. So when I investigated, there were cases wherein PC1 was deemed non-trivial, PC2 was deemed trivial, pero si PC3 tinatag ulit niya na non-trivial, which do not make sense in the context of PCA. So I did a tweak. So ang naging decision point ay hindi lang siya basta based on the number of significant PC loadings. It will be the number of adjacent na non-trivial PCs. Okay, so each scenario consists of 100 replicates. For each replicate, the number of non-trivial PCs suggested by the three methods were recorded. And what I will be presenting is the proportion of test data na natatag natin na correct. Okay? So the results are as follows. Medyo matagal po yung run, kaya limited yung correlation structure na nagawa ko. I think nag-run for 3 days straight yung program to generate or to explore itong method na ito. So for the first correlation structure, tinest out lang natin, no? What if there are no correlated variables and the pairwise correlations are at 0.1 lang? So dapat wala tayo makikita na non-trivial PC dito, no? And for this one, the bootstrap eigenvector dominated the other two methods. Kung makikita nyo, the boot eigenvalue and the Kaiser-Gottman, lagi silang mas mataas sa 1 yung sinasuggest nila na number of PCs to retain, no? Which at this context is hindi tama. So for this one, the boot eigenvector is the best method, no? However, we will note na when we're dealing with a large sample size, naka-observe tayo ng decrease or poor performance. And if we look at the adjusted sig level, yes, no, we will notice na the adjustment seems to work kasi from 0.74, bumabagsak sa 0.41 if you remove the adjustment, no? And the reason for that is because pag adjusted yan, mas malalawak or mas malalapad yung mga CIs. At possibly, nung hindi adjusted, hindi niya nako-cover yung 0, pero pag adjusted na siya, tinatamaan niya yung 0. Okay, so the second correlation structure ay yan. Okay, sorry for that. So yung second correlation structure naman, we have one group of highly correlated variables. Okay, so for this one, we have a set of 4 variables. Ang correlation nila is 0.9. And you will notice that the bootstrap eigenvector approach still dominated the other two methods. For this one, there is a marked improvement on the performance for n equal to 300. Pero that is only true kapag adjusted sig level yung ginagamit natin. For the third correlation structure, we have 2 groups of highly correlated variables. 4 variables have a correlation of 0.9, 3 have a correlation of 0.7. Outside of their group, no, hindi na sila correlated dun sa ibang mga variables. So for this one, the bootstrap eigenvector performed better than the other two methods across all sub-scenarios, although improvements in the performance of the other methods were observed. So again, we will notice that adjustment to the significance level seems to work kasi improved yung kanyang proportion of correctly identified number of PCs. Okay. Now for the fourth one, we have 2 groups of moderately correlated variables. So 0.5 and 0.4 yung ginamit natin na correlation. And the bootstrap eigenvector approach yielded more correct decisions across all scenarios, no? Although hindi na siya dominating in the sense na hindi masyadong malayo yung kanyang yielded proportion. So what is weird with this result is that yung kaninang nakita natin that adjusting the sig level seems to work no longer applies kapag mababa yung sample. This is something that I need to explore further kasi at this point, no, hindi ko siya ma-explain. And then for the fifth one, 3 groups of moderately correlated variables. And again, you will notice na unti-unting nade-deteriorate yung performance of the bootstrap eigenvector approach. So another important note here is that the heuristic approach, Kaiser-Gottman, nakita nyo, no, mataas na yung kanyang tinatama. Okay? Kapag nandito tayo sa specific to correlation structure na ito. And at the same time, si boot eigenvalue, lagi siyang second or lagi siyang nahuhuli, no, in comparison to the boot eigenvector approach. But this time, I think there is already a reversal in terms of kung sino yung mas madalas na tumatama. And for our last correlation structure, we have one group of weakly correlated variables. So in-explore lang natin what if we have 5 variables out of the 10 na 0.3 lang yung kanilang correlation structure, which based on my readings is very rarely silang makakita sa ecological setting or evolutionary biology setting na matataas talaga or highly correlated. So similar to scenario 5, no unanimous winner among the 3 methods, but si bootstrap eigenvector ay talagang nag-struggle in terms of suggesting the correct number of non-trivial PCs. So the bootstrap eigenvalue approach worked best when dealing with n equal to 100. So performance decline when we have a sample size. My theory or my hypothesis is that for larger sample sizes, there is a generally increased precision in terms of the estimates. Kaya yung mga CIs ay nag-shorten. Okay, especially for the bootstrap eigenvector. So summarizing the results, no? Kasi ito yung target ko talaga. In the presence of outliers, mami-minimize ba natin yung effect nila once we try to determine the number of pieces to retain? And I can say that the outlier detection procedure seems to work because even though yung no outlier ay consistently mas mataas across all methods, I can say na it's just a marginal improvement in terms of the proportion of correctly identified number of non-trivial PCs. So, yung objective na malaman kung effective yung pag-minimize natin ng effect ng outlier is seems to work na minimize talaga niya yung effect. And then for the correlation structure, ito yung main problem, no? For different correlation structures, iba-iba yung nagiging mas okay na approach. So later on, I will have a suggestion kung paano natin masosolve ito. Okay? And in terms of sample size, nagkakaroon tayo ng problem for relatively larger sample size. So this is something that I'm going to further explore sa mga susunod na simulation studies ko. And then for adjusting the confidence level, point of contention din to, no, if you really need to adjust the confidence level, because at this point, even though there is an indication na better yung merong adjusted na sig level, it seems that marginal din yung improvement. Okay? So for my next steps, and if in case interested kayo to also work on this problem, there seems to be an opportunity to improve the decision in determining the number of non-trivial pieces to retain by combining yung dalawang bootstrap approaches. So wala naman talagang nagre-restrict kung isa lang ba yung pwedeng gamitin out of the 2 approaches, no? So I'll try to explore what will happen if i-combine natin yung kanilang results. And then revisit the outlier detection capability because for larger sample sizes, maybe may mga napapasama na mas maraming outliers, no? And part of siguro of the next simulation runs is to also monitor kung may nasasama ba na outliers dun sa supposedly cleaned dataset. And then we also need to consider more correlation structure scenarios and possibly to use actual data. Titignan natin kung ano yung magiging result if we apply it to actual data. Okay? So I guess that will be it for my short lecture. Maraming salamat sa pakikinig. And If you have any questions, please feel free to either raise your hand siguro or use the chat box.
Maraming salamat po, Prof. Martin, sa inyong presentation. Very interesting study po. And I'm sure yung mga participants po natin na umattend din last year ay nakita po nila yung development sa inyong study. And I'm sure excited din po yung iba na masubaybayan yung magiging development po sa susunod na lecture po ninyo. So thank you so much po. Let's now open the floor para po sa mga questions from our audience members. So pwede po ninyong gamitin yung ating raise hand function or pwede po kayong mag-chat kung meron po kayong questions. Sige po. Habang hinihintay po natin yung iba na siguro ma-articulate po nila yung kanilang question, meron lang po tayong question dito. Prof. Martin, pwede po bang pa-summarize po ng scenarios kung saan yung bootstrap eigenvector works better than the other methods? And bakit po kaya sa tingin nyo siya nag-work better than others?
So, in general, no, nag-work siya kapag, well, una, wala talagang non-trivial PC. That's the first scenario, no? And then, kapag isa or dalawa lang yung non-trivial PCs. Okay? So at this point, I'm really not sure, but ang possible explanation siguro ay by the way, no, sample size seems also to be a factor, no? So since sa eigenvector, so kung gaano karami yung variables mo, that's also the same number of elements in your eigenvector, no? So you have a p number of CIs there, and I think no nagiging problem or issue din dito is yung sa adjustment na minsan nasa bingit lang siya ng 0 kasi yung 0 yung target natin doon. If 0 is part of the CI, ibig sabihin hindi significant yung element of the eigenvector na yon. And the reason why we are tagging it as a non-trivial PC is more at least 2 yung significant na element ng eigenvector. So, na-encounter ko rin to dun sa ginawa kong or dun sa thesis ko, no, na it seems that mayroong bias ng konti in the sense that kailangan mo lang iusod ng konti or baka kailangan may adjustment dun sa nakukuha na value. Okay? So, I think hindi ko pa ako makapagbigay ng definite answer, no? I still need to also explore yung theory mismo kasi ito ay simulation study. We're just trying to figure out patterns. So hopefully, no, makabuo tayo or makita natin yung theory that will explain bakit ganito yung nagiging performance.
Okay po. Thank you, Prof. Martin. Meron pa po tayong questions dito. Meron po tayo from Marty Banyaga. Kung meron po daw bang missing data yung ating dataset, suitable pa rin po ba yung proposed methods po ninyo for PCA?
Well, for now, no, we did not consider the case for missing data. And I think magiging approach dito for now is, well, ina-assume natin na lahat kompleto yung data natin. So if you have missing data, most likely you will be needing to do some imputation. Okay, so hindi ko pa na-explore yan, but the way we do PCA, so may assumption tayo na kompleto yung data natin.
Okay po, thank you po. We also have another question here from Prof. Sopranes po. Since the method aims to identify non-trivial PCs, do you think the approach can be used or retrofitted for testing the unidimensionality of a psych test or diagnostic questionnaire?
Yeah. Thank you, Sir Van, for the question. So definitely, pwede naman siyang gamitin, no? Ang mangyayari lang is, it's really a test kung isa lang yung ma-retain because we're talking about unidimensionality. Siguro ang dapat i-account is, ang approach pa lang natin ngayon ay PCA So I think yung pag-analyze ng psych test or a diagnostic questionnaire is more of factor analysis. Although sa factor analysis, merong extraction procedure na principal components. So we just need, currently dun tayo sa case na PCA yung ginagamit natin. So kung PCA yung approach in creating an index para dito sa test na to, so yeah, magagamit natin ito for testing unidimensionality. So ano lang, specific lang tayo that there's only one PC na mare-retain when we do our analysis.
Okay, thank you po. Thank you din sa mga lagay ng kanilang questions sa ating chat box. Sa iba pong may questions, pwede po kayong raise hand or pwede po kayong mag-chat. Meron pa po tayo ditong question, Prof. Martin. Nabanggit niyo po kanina yung tungkol sa relationship ng performance ng method sa sample size. Pero may question lang po dito, kung meron po ba kayong idea kung paano natin i-deal yung siguro larger sample sizes than what you tested at kung ano po yung sa tingin yung magiging performance ng methods?
Well, based on the pattern na nakita natin, no, it seems na pag nilakyan ba natin, mas magkakaroon tayo ng problem. Pero dun lang sa approach number 2. Kasi parang nung nag-improve yung performance ni eigenvalue-based approach at kay eigenvector-based approach, no, nakakita din tayo ng pattern na may effect din si sample size. So yun yung itatry kong gawin na i-combine natin yung result nilang dalawa. So kumbaga, for us to be able to tag a PC na non-trivial, dapat matag siya ni approach 1 at ni approach 2 ng sabay. So otherwise, no, kung isa lang yung makakapag-tag, we will not take it as a non-trivial PC. So parang mas magiging mahigpit lang tayo. It will be an end condition, not an or condition. So yun yung isang approach. Another one is, itong ginawa ko kasing eigenvalue or yung bootstrap-based CI based on the eigenvalue. Ang tawag dito is bootstrap Kaiser-Guttman rule. Kasi ang hinahanap lang natin, we don't want a CI na hindi included si 1. Yun yung gusto natin, sorry. Gusto natin na more than 1 or hindi kasama si 1 dun sa CI natin. But there is another approach na pwede ko ring itry, which is for a PC to be non-trivial, dapat yung katabi niyang PC, yung CI ng katabi niyang PC, hindi dapat sila nag-overlap. Kasi an overlap dun sa kanilang CI means that virtually indistinguishable sila, which means that hindi sila interpretable. Okay, so yun.
Okay, sige, maraming salamat po Prof. Martin sa pagbahagi po ng inyong exploratory study, and we look forward po sa continuation. Hopefully next year po marinig po namin yung bagong development sa inyong pag-aaral. Sige po, bilang pasasalamat sa ating speaker kay Prof. Martin, we are awarding the Certificate of Appreciation to Prof. Martin Augustine B. Borlongan, 2021 Robert Coyuito Professorial Chair in Statistics, for his excellent lecture entitled Testing for Non-Trivial Principal Components in the Presence of Outliers, given this 16th day of December 2021 via Zoom. Signed by our Dean, Dr. Joseph Ryan G. Lansangan of UP School of Statistics, and Dr. Imogen F. Evidente, our Director for Research sa UP School of Statistics. So maraming salamat po ulit sa pagbabahagi ng inyong time and expertise.
Thank you very much din po for listening to my lecture.
Thank you po, Prof. Okay, so for our next speaker, ready na ang ating next speaker. Ang next speaker natin ay si Professor Francisco N. de los Reyes. So Prof. de los Reyes is the 2021 Angeles Buenaventura Professorial Chair in Statistics. He is an Associate Professor of the School of Statistics and is currently the Director of the Office of Admissions for the UP system. He is a published academic whose interests are in statistical process control, spatial statistics, and biostatistics. He was awarded the Sun Life Brilliance Professorial Chair for Statistics in 2017 and the UP Centennial Professorial Chair in 2020 and the Gawad Chancellor sa Natatanging Guro in 2020 as well. Prof. De Los Reyes was also a statistician for various researches in government, industry, academe, and training institutions, and is currently a measurement science and data analytics practitioner. He is also a member of Phi Kappa Phi and Pi Gamma Mu International Honor Societies for academic excellence. So let's all give our virtual warm of applause to Professor Kiko Francisco de los Reyes. So magandang hapon po.
Magandang hapon sa inyong lahat. Is my audio clear?
Yes po, Prof.
Okay, thank you very much. It has been a long day pero I'm really excited to be with you this afternoon. Pangatlong speaking engagement for the day. Itong gagawin kong Professorial Chair Lecture, but I cannot pass it up because it's very special to me, not only because it is a Professorial Chair, but because it was through Angeles Buenaventura. Okay? So, mas mabigat yon na commitment that I am delivering this in honor of a beloved professor. Let me just give me some time to click on my presentation. Okay. So my title is Going Hardcore. It gives modeling for inhibition processes. So when I received the notice of award of the professorial chair, it was explicitly stated there that I had to develop an original piece for this afternoon. So I really took time and took a longer time than the usual to develop this because I think I owe it to Ma'am Buena and to the audience to deliver a substantial lecture that does not only provide theory but also provide some insights on real data where this theory can help. I am Francisco N. de los Reyes. I am the recipient of the Angeles Buenaventura Professorial Chair in Statistics 2021. Before I begin my lecture, I would just like to say something about the professorial chair, no, to whom it is named. No, the professor is Angeles R. Buenaventura. I am happy and proud that I was in her class in the Philippine Statistical System. Parang Philippine Official Statistics kasi yung pangalan ng course namin noon. It was stat 169. It was through her that I got to know how intricate our statistical system is, and it is through her class that I was exposed as an intern at the Bureau of Agricultural Statistics then. So I, as part of the requirements in stat 169, we have to be present half the time, no? Parang half the semester. We go to BAS. Like, iba-iba kami ng pinuntahan, pero ako na-assign ako sa Bureau of Agricultural Statistics. And through that exposure, I got to know the nuances of the rice and corn survey, the sampling design, the field manuals that we had to understand as interns, and then provide technical support to the employees of the BAS, no? Even to the point of providing assistance to some field work for nearby endeavors. Kapag nasa Metro Manila lang, tapos kailangan ng price monitoring ng mga basic agricultural goods, no, sumasama kami noon. Pero magandang exposure yon kasi natutunan namin kung paano talaga maging isang statistician for the people. Now, when I was contemplating on the topic that I had to present on Ma'am Buena's honor, I had to make it I have to give a title that is true to her character, which is hardcore. Si Ma'am Buena kasi talaga is a personality. No, she has a very morbid wit, and she has a no holds barred attitude in many things. She was in an advanced age, as you can see, even during the time that we were in the undergraduate program. Matanda na talaga siya noon, but she doesn't want to be called matanda. No? So she's a fashionista. No? The palette that you see on screen now is Ma'am Buena. It's a mix of a pink, an orange, a red, magenta, purple. That will be her um, OOTD colors. So she's also hardcore in terms of supporting the activities of the Philippine Statistical Association. And in fact, I unearthed a very old photograph of the board of directors of the PSAI, no, in the early 90s. I was the youngest member of this board of directors. You can see me there with the collarless shirt, and Ma'am Buena as the one sitting at the far right. But until her death in 2011, she was really very active as a supporter of the Philippine statistical system, and still present in various events, both academic and otherwise, at the School of Statistics. So that's just for the audience to know who Ma'am Buena is. So kilala niyo kung kanino nakapangalan itong professorial chair na ito. So in honor of Ma'am Buena, this is Going Hardcore Gibbs Modeling for Inhibition Processes. So the outline of my talk, I will introduce you to what is a hardcore process. Then I will discuss the model, the procedure on how to fit, and then how to do prediction. Then we will discuss certain measures on the goodness of fit and the diagnostics. So how do we see the adequacy of the model? And then we will apply this to a geophysical phenomenon in the Philippines. So as a motivation, typically, when we have a point process, ano ba yung point process? It's a realization of a stochastic mechanism wherein you are looking at events in space. These are discrete locations, di ba? So pagpalagay ninyo, yung mga nunal sa likuran ninyo, no? Those are point patterns. The way big trees are distributed over campus, these are point patterns. The garbage that is scattered on the ground is a point pattern. So you see discrete locations, di ba? Saan nakalagay ito mga events na to. So ang baseline hypothesis sa kanila is it's just completely random. Parang the way points are located in space is just random. And we call that technically as a complete spatial randomness. Now, syempre, kapag completely random lang spatially, it's very easy to model. You just appeal to the regular Poisson process, the homogeneous one. Di ba? The thing that we learned in school, right? In our basic statistics class, the Poisson distribution, wherein you have a mean, which is actually an intensity multiplied to an area, right? So it's lambda times A. The mu that we have, actually lambda ginagamit nating notation sa probability theory. So lambda, which is the mean that we see, is actually an intensity multiplied to an area, right? So you see that you make two mistakes in one bond paper. So technically, you have an intensity multiplied to the area of the bond paper, and that's just 2, right? So we just use that to assess probabilities, conduct our inferences, perform regression modeling through the Poisson, etc. But the undertone is you just look at the scatter of the events in a particular slice of space as completely random. Pero paano kung hindi? Diba? Paano kung hindi? If there is a departure from complete spatial randomness, and typically the departure is basically either a clustering or a repulsion, how do you attack a particular problem? So kailangan mo ngayon ng isang pag-aaral, no? Kailangan mo ngayon i-characterize yung nature ng spatial dependence when you have deviated, when you see a deviation already from complete spatial randomness. Now, in the elementary or fundamental way of teaching spatial stat, we appeal to typical or more popular techniques, no? So doon sa mga nag-stat 276 o mga nag-stat 197, inaral doon yung nearest neighbor, di ba? So we plot the F function, the G function, okay, which are actually an empirical distribution function of the nearest neighbors, di ba? So pag masyadong maraming maliliit na nearest neighbor, we conclude na merong clustering. Pag masyadong maraming maliliit na malalaking nearest neighbors, merong tayong repulsion. O kaya yung K function natin, which is like a trace, like an ECG, and then we compute a simulation envelope and see whether that trace is within that envelope. Conclude na meron ka pang randomness, pero pag lumabas na siya doon, magko-conclude ka na ng spatial dependence. Okay? Pero, ang problema, general conclusions lang yon. Sinasabi mo lang na merong clustering, sinasabi mo lang na merong repulsion. Pero pag sinabi mong, oh sir, meron po akong repulsion na nakikita kasi sabi nung K function may repulsion daw. Confirm na yon kasi inferential method yon. So, what's next? Diba? Hindi mo na alam, right? So ngayon, kailangan natin ng quantifier. Ano ba yung repulsion distance? How do you measure it? So if you are, let's say, if you're a marketer and you are placing branches of your brand, no? Let's say your brand is a specialty clinic or a quick service restaurant, di ba? So hindi naman pwede magkatabi palagi yan. Magkakaroon yan ng isang critical distance na dapat hindi kayo ganun magkasing tabi. Right? So you have to measure that and you have to establish that. And in the larger scheme of things, what is that optimal distance? Later on, we will call that the hardcore constraint. There arises a need for a model that accommodates attraction and repulsion across varying scales of spatial dependence. In reality kasi, you do not really see a pattern which is completely clustered or completely inhibited or completely repulsed. At some point, there will be clustering. At some point, there will be repulsion. So think of the National Capital Region, di ba? So tingnan mo, pag naglagay ka ng mga, tingnan mo yung mga lokasyon kung saan naroon ang LBC or saan naroon ang Western Union. There will be points in the NCR where there will be some clustering of these branches. Pero if you go down south or you go further north bordering on Bulacan, mas kaunti yung branches dyan. Okay? So at some point, there will be repulsion, but there are points in the region wherein there will be clustering. So this wide variety in this range of scale has to be accommodated. So you have to pinpoint at which particular point or which particular slice of the land you have clustering and which particular slice of the land do you have the repulsion. Okay. So under the homogeneous model, ang intensity natin pantay-pantay, di ba? When we learn Poisson modeling, di ba? That's our go-to probability model when we're looking at events scattered in space or in an interval of time. Di ba? Typically, that's what we do. And then we assume that the chances of an event occurring in this very small piece of area or very small interval of time will be independent, di ba? Yung mga events na yan. Tapos yung probability na mag-occur sila dyan in these very small spaces together, di ba? So para sabihin mo na halos equal yon. Okay. Now, in spatial dependence, when there is in spatial independence or under complete spatial randomness, we look at lambda. No? In my talk, this will be denoted as lambda. It is an intensity, the same way we understand our intensity in our regular Poisson distribution. So nasanay lang tayo na mean palagi yung binibigay sa atin, pero actually that mean is a product of an intensity and a size of a region. Okay, so intensity is this limit. No? You can think of it conceptually. Given any point, sa spatial statistics kasi, if you denote this the location S as an underscore, it actually has two things involved in it. S will be written as a coordinate system. So S1, S2, the longitude and the latitude. And in this talk, I have converted already the long lat into the decimal degrees version na nasa Cartesian na siya. So you'll be seeing like 120 something something, comma 20 point something something. Okay, so Cartesian na siya, naka-convert na siya aside instead of the degrees north, degrees west, etc., etc. So at lambda at s, no, so this is now the intensity that you have in this particular point, and then this is defined as the limit as ds without any underscore, as ds goes to 0 of the expectation of y at ds with an underscore over ds without an underscore. The ds with an underscore is a region. No, think of s underscore as an arbitrary region, and then there's a small circle surrounding it. Okay, and that small circle has area ds without an underscore, and you let that area tend to 0. Okay, so that is our theoretical definition of what the intensity is. Okay. The first order properties, when we say first order, you are typifying the intensity as a mean and as a variance. In the homogeneous Poisson distribution, the lambda multiplied to the area of the region W is the mean, and it's also the variance, right? So yun yung isang property ng homogeneous Poisson process. Wherever you are in the study region, right? What if you have intensity in the northeast at this particular level 1.6, and then as you move southeast or southwest, you have 0.9 na lang, or siguro 0.03. Diba? So hindi na pantay-pantay yung intensity, diba? So meron ng dependence where you are. It depends now on where you are in the study region. So in that sense, the definition of the lambda that we see here does not really hold. We need to find a dependence. We need to condition the intensity whether as relative to where you are. Okay, so that's the concept of conditional intensity. So suppose for a point process X and a location S, we look at the intensity at S, given the rest of the point pattern X as lambda at S, given the point pattern. Okay, so we call that the conditional intensity. So let's have a definition. For a point pattern X with probability density f of X, the conditional intensity at a location U given X, where U is not in X, is given by this, no? Lambda at U given X. So in this case, I abused lang the notation. Actually, I did not write the underscore anymore because U now is a unary, parang lokasyon lang siya, no? So parang that will be any point. Okay, so this will be the density of X where U is included. So X union U over f of X. Here U is not in the inclusion. Okay, so note that the conditional intensity at the point X is given by lambda xi over S. Ito, yung U dito, hindi siya kasama dun sa pattern X. Dito naman sa definition dito sa baba, yung X kasama na siya doon sa point pattern itself. But we compute lambda at xi given X as the joint density. This is already joint distribution kasi yung X dito naka-bold. So think of this as a joint density, yung f of X dito, over f of X without a particular point location. So think of, kunwari, point pattern sa ating parking lot, di ba? Tapos may isang basura na nakakalat malapit doon sa isang pole. Pag tinanggal mo yon, yun yung X \X sub I. No? So ano yung density nung wala siya? Okay. Now, what is a hardcore process? When events in a point process exhibit regularity, regularity is an interchangeable term with repulsion in spatial statistics. Basta hindi inhibited or hindi completely random, pwede mo sabihin as regular or repulsed. No? In that a distance h may be found for which any pair of events are at least h units apart. The process is said to have a hardcore constraint. Okay? So yung constraint na ito, ibig sabihin, no two events will be nearer each other. Diba? Kasi merong isang event na dapat ganun sila kalayo. Think of large trees. Diba? Naturally, yung mga malalaking puno, malalayo sa isa't isa yan. Kasi kung tatabi yung isang puno sa katabi niyang malaking puno, wala siyang sunlight. 'di ba? So mag-aaway sila, magkakaroon sila ng competition, no, sa sunlight. So typically large trees are far apart and there will be an inhibition distance between them. That inhibition distance is our hardcore constraint. For modeling purposes, we consider a point process model that is completely random, subject to the hardcore constraint. This model has the probability density f of x equals C null beta to the nx if hardcore is satisfied and 0 if hardcore is violated. So pag sinabing merong satisfaction ng hardcore, yung mga points, no, doon sa region ay separated by at least R, or in this case H, no? So kunwari yung mga branches ng Jollibee, yung mga branches ng Jollibee, dapat hindi sila magkalapit by less than 50 meters, 'di ba? Kasi may mga Jollibee magkakatabi, magkakatapat, 'di ba? You can see that, right? Diyan lang sa may Eastwood area, diyan sa may sa may Valle Verde, there's a big Jollibee, and then right across beside Starbucks is another Jollibee. So parang dapat meron man lang hardcore distance, 'di ba? Dapat meron man lang ma-establish na parang 20 meters away lang there's another branch na eh. So dapat for a hardcore to be present in the point process, merong nire-respect na distansya between one event to another event, no? So any pair must satisfy or must respect that inhibition distance. So where C null is some constant, beta is the intensity of the homogeneous boson process in the study region W, and n of x is the number of events. Sorry. Okay. So one version of the hardcore is the Strauss process. Sa hardcore kasi, kaya siya hardcore, kailangan lahat masatisfy yung inhibition distance. Kapag hindi na satisfy yung inhibition distance, pwedeng i-thin out yung event na yon. And pwede naman sa R, nagagawa yun ng SP-thin. There is a package that does that. No? So halimbawa, meron kang sabog ng points. Tapos alam mo naman na majority of them are inhibited. Pero there are a couple of points na parang ang lapit sa isa't isa. If that particular pair does not respect the hardcore constraint, pwedeng ma-thin out yung isa sa kanila para ang maiiwang process ay nagre-respect na dun sa hardcore. Okay? So ngayon, pwedeng hindi yun gawin, no? Kasi like ako, kung ako yung marketer ng isang brand, ayoko tanggalin yung ibang mga branch. Gusto ko makita lahat. Right? So ang gagawin ko na lang, mag-i-impose na lang ako ng penalty doon sa mga hindi nagre-respect ng hardcore distance. Okay? So this is called the Strauss process. No? Events may realize as close in space. Pwedeng hindi nila ma-satisfy yung hardcore constraint, pero kapag nangyari yon, may penalty sila. Right? Hindi sila matatanggal doon sa entire point process. Okay? Kasi ako, I'd rather analyze the full point process rather than the sample frame. So I go to analyzing the entire field, no? And then the Strauss process allows me to accommodate all the points but give penalty to those that do not respect the hardcore constraint. Okay, so the probability model f of x is now C sub star, beta to the nx, gamma to the sxr. So C star is some constant, no, that we typically tune, no? And then beta is called the abundance parameter. Dahil sa Strauss context, hindi natin masyadong ginagamit yung intensity kasi pag sinabi intensity, flat yun eh, no? So we may say that the beta is a conditional intensity analog. So the safer term is an abundance parameter. Gamma is a parameter also known as the interaction parameter. It's a number from 0 to 1. And then S is the number of unordered pairs of events in X which are closer than the interaction distance R. Okay. the conditional intensity of the Strauss process is lambda at u given x, which is beta times gamma to the t, where t is dependent on has the argument u, the particular point location, the inhibition distance r, okay, and then the point pattern x. Okay, so actually ano lang yan, count lang yan, no? So let u be any randomly scattered point, no? Kasi lambda at u given x eh. Tapos bibigyan mo siya ng inhibition distance, let's say 20 meters. Given the point pattern x, ilan yung mga event na malapit sa kanya within 20 meters sa kanya? 'Di ba? So kung isa 'yon, edi t is equal to 1. Kung 5 'yon, di t equals 5. Right? Basta count lang siya. Okay? The Strauss process is in between complete spatial randomness and the full hardcore. So the two extremes are the CSR and the hardcore process. Sa hardcore, kailangan lahat. 'Di ba? Kailangan lahat ay malayo sa isa't isa by more than, let's say, h or r. No? Basta isang inhibition distance. Remember, sa Strauss, pwede kayong mas malapit less than r, let's say less than 20 meters, pero may penalty lang kayo. When gamma is equal to 1, the realization is deemed as emanating from a homogeneous boson, thus CSR. When gamma is 0, the realization is trimmed such that no pair of events are close to each other, thus a hardcore process. The Strauss process was originally meant to model clustering. Looking back at the seminal work by Strauss in 1975, pero pinakita doon na yung gamma of greater than 1, no, renders the function f of x equals c null beta to the n, gamma to the s as non-integrable. Si Ripley, isa sa mga main authors that you see in literature for spatial statistics, and disqualifies it as a proper PDF. So how do we fit the Gibbs model? We consider a point process with probability density f of x equals c sub theta e to the beta x plus gamma, theta prime. It's a vector operation, no? So it's a theta prime s. Okay, so theta here is vector based. Okay, so it's a vector base of canonical parameters, and S is a known vector valued sufficient statistic, and C sub theta is a constant that depends on theta. Okay, so itong nasa taas, itong power na exponential, optional yung B, no? Ito, ang tawag dito is baseline function or offset. Okay, so kung halimbawa sa applications sa epidemiology, for example, you're analyzing disease rates, but you are looking at a data with excess rate, risk rate, no? You may choose to put that as an offset. So parang tatanggalin mo yung excess. Halimbawa, kunwari, you're studying maternal mortality, tapos nag-aaral ka sa isang lugar, inaaral mo isang lugar na medyo mataas than the national rate yung maternal mortality. So that distance from the national level to the elevated risk could be deemed as the baseline function or the offset. Okay? So yun yung B mo dyan. Yung theta S, typically, ano yan? Mga, kunwari, linear form of X. Remember, yung X natin dito, spatial coordinate yan most likely. So ang laman yan, northing tsaka easting. Nasaan siya in the longitude tsaka in the latitude. So if you look at X as a coordinate XY, kung linear yung trend, yung e to the something times easting plus something times northing. Pwedeng yun yung theta prime S. O kaya pwedeng ito ay something times the easting plus something times the northing plus something times the product of the easting and the northing. Pwede namang merong quadratic term, nakasquare yung easting pa, nakasquare pa yung northing, or you can have it a polynomial of higher order. Or in some cases na meron kang additional information, pwedeng meron ka pang halimbawa slope at that particular location, elevation at that particular location, o kaya kung halimbawa merong risk element, kunwari merong malapit na incinerator tapos inaaral mo sakit sa baga, yung distance ng lokasyon ng disease ng taong na may sakit doon sa incinerator could be part of that term. Okay, so maraming pwedeng ilagay dyan. Okay, so if you look at it closer and if you expand your view, f of x could be a transformation of the density na naka-incorporate yung mga covariates as part of an exponential family. Okay, so yan yung essence ng f of x dyan. As classically practiced, the typical mode of inference is via the likelihood function. However, extreme difficulty is encountered in Gibbs models due to complications in the density. Okay, so the likelihood of the Gibbs hardcore process, which is really the Poisson respecting hardcore, is given by the following. So the density is some alpha times the abundance parameter to the number nx, e to the 1 minus beta. The W in bars is just the area of your study region. No? So if hardcore is respected, and then the PDF is 0 otherwise. So alpha is 1 over P. It is the normalizing constant where P is the probability that the Poisson process respects the hardcore. And note that P is equal to, is a function which is, it is affected by BWH. No? Is a decreasing function of H, the inhibition distance, and the abundance parameter, thus making alpha dependent on HSB as well. For fixed beta, the likelihood L beta H is given as follows, no? And the MLE of the hardcore distance is easily derivable, if there's such a word. It's easily derived. Okay, so the MLE is actually Diliman, the smallest inter-event distance. So that's the MLE. So kapag mag-nominate tayo ng Strauss model, dadaan muna tayo sa hardcore process para ma-estimate natin kung ano yung hardcore distance, and then we proceed to the Strauss modeling. Okay, so that's the first step actually. You need to establish the inhibition distance. And luckily, we have an MLE, no? The smallest inter-event distance is your maximum likelihood estimator for that inhibition parameter. Some literature scan, the search for the MLE of beta has been embarked. Remember, when we found the MLE for the inhibition distance, we have fixed beta. But that is not always the case. Diba? Remember, beta is intensity, and under the hardcore, nag-iiba-iba yung intensity niyan. Diba? So hindi pwedeng uubra talaga na fix yung beta. Pero starting point to estimate the hardcore distance is to let beta be flat. Just see ano yung pinakamaliit na inter-event distance, kasi hanggang doon lang naman yung gusto mong malaman. Okay, so the MLE of beta has been embarked on by various authors, Ogata and Tanemura, in various years from 1981 to 2003, with co-author Katsura in 1988, 1991, and 2003. Pentinen 1984 explored on Monte Carlo MLE. Moyid and Badeli, another very prominent and prolific author in spatial statistics in 91, worked on stochastic approximation. And Mays 1992, who studied the asymptotic theory of the maximum likelihood. Now, ang gagamitin natin sa pag-analyze ng data is kasi nga mahirap mag-perform ng MLE kapag hindi fix yung beta. So si Besag and Sarka propose to maximize the log pseudo likelihood instead. Okay, so log PL, given the theta there is vector, it's a vector vector-based parameter, no? So it's a vector of parameters, and x is the point pattern. It's the summation of log of theta of lambda sub theta xi given x minus the integral over the study region of lambda sub theta u given x du. The maximum pseudo likelihood estimator MPLE was found to be asymptotically unbiased, consistent, and asymptotically normal. The advantage is lambda at u is easy to compute and maximize, and then the disadvantage is it is inefficient for small collection of events. Actually, I encountered this in the data set that I have analyzed. I was concentrating on Mindanao only, but it appears that I have insufficiency of data. Kasi nga inhibited, di ba? Malalayo si set isa. So kulang ako sa data, so hindi ako makakuha ng convergence, ang lalaki ng mga variance. Pag nakakuha naman ako ng estimator, ang lalaki ng variance. No? So nakita ko yung disadvantage ng MPLE doon sa actual data na ito. Now, the one which is, kasi medyo nag-cold case yung nag-cold case yung estimation, yung search for the better estimation process dito sa Gibbs modeling. No? Ang pinaka quote-unquote bago, which is already 20 years old, is the Baddeley and Turner approach. No? And actually, this one is implementable na in R. Nagagawa na to. Merong addition, merong konting tweak lang na binigay si Huang and Ogata, but si Baddeley and Turner, sila na yung parang lumalabas na proponent ng pinaka-recent na technique. Propose an algorithm for maximum pseudo likelihood. They consider the log linear form of the parameter in theta. So makikita mo ngayon, i-model natin through log linear, no, yung log ng conditional intensity as using this function bu plus theta prime z. Okay, so yung bu again is an offset or a baseline. Optional yan. Pwedeng wala yan. Pwedeng log lambda sub theta equals theta prime z. Okay? Pero pwedeng lagyan siya. No? Yung z, again, is another real valued function. So theta prime z. Yung z, again, pwede siyang linear trend, pwede siyang linear trend with interaction, pwede siyang quadratic in x but linear in y, etc. No? Pwede ka magbigay ng kung ano-anong version ng trend surface. No? Kasi remember, ang meron ka talagang datos ay longitude, latitude, yung point location. Ang data natin sa Gibbs model ay point location lang. So kung meron kang 100 lindol, no? Nasaan lang ano lang yung long lat ng lindol na yun lang yung data mo dito. Magagawa mo na to. Okay? So ang ingenuity lang dito is paano mo titimplahin yung trend surface ng x and y. What particular trend surface do you want to build? Okay? For the Strauss process, this is equivalent to log lambda at u given x, which is log beta plus log gamma t at u r x, such that theta is log beta log gamma. Here, t is the number of events in x which lie within the distance r from the location u. So again, count lang yung t na yan. Si Huang at saka si Ogata propose a one-step approximation to the maximum likelihood. No? So ito yung together with the approach by Baddeley and Turner in 2000, a year earlier, si Huang and Ogata, meron siyang pinpropose, no, na approximation sa maximum likelihood na ginamit dito. Okay? So, ano yung steps? This is just the sketch of the steps. We fit the log linear function for log lambda using maximum pseudo likelihood. The Baddeley-Turner technique is a good candidate approach. Simulate m independent realizations using the fitted parameter. Refer to the likelihood score u equals s of x minus the expected value of s of x, and the Fisher information I theta, which is the variance of s. So actually, this is a covariance matrix. This is a covariance matrix. The likelihood score evaluated at theta hat at the maximum pseudo likelihood, which we call u at theta hat MPLX, is approximated by u bar equals s of x minus s bar, where s bar is 1 over m, summation I from 1 to m, of s at x super I. Okay, so nung wala yung I. The Fisher information evaluated at the MPL, which is I sub theta hat MPL, is estimated by I bar equals 1 over m, summation I from 1 to m, s of x super I times s of x super I transpose, okay, minus s bar transpose. Okay. So vector yang s na yan, vector of functions, no? So the parameter estimate is updated by the Newton-Raphson to give theta hat equals theta hat MPL plus u bar minus u bar inverse u bar. May problema lang akong na-encounter dito. When I was fitting this in my model and I was hypothesizing a higher order polynomial, I am getting singular Fisher information matrix already. So na-inhibit. So na-inhibit ako to proceed with higher order. Kasi sa, 'di ba, the higher order polynomial you include, the more points of inflection you introduce, 'di ba, in the trend surface. I was hoping sana to introduce more. Pero hindi nga eh. Based on the data, because I only have 84 landslides in my study, hindi na ako maka-achieve ng non-singular na Fisher information. So I had to stop at some point and just assess the models where the matrices can be inverted, specifically the information matrix. Okay. Now, so yun yung paraan ng ang maging output mo dito is malalaman mo kung ano yung intensity. Siyempre na-establish mo na sa simula kung ano yung inhibition distance, ma-establish mo yung intensity, ma-establish mo yung model that can estimate the conditional intensity and then predict ano yung conditional intensity mo in a particular map. So kahit ang datos mo ay mga point location, you have to make a version of your map where you rasterize. Yung parang i-identify mo talaga, gagawa ka ng grid kahit wala namang event doon para lang magkaroon ka lang ng coordinate para ma-predict mo yung intensity doon sa lugar na yon. Kasi maski wala talagang event, pero malapit siya sa mga event, yung intensity niyan medyo mataas pa rin ng konti. Okay? So paano naman ina-assess ang goodness of fit? The standard GOF tests based on the CDF, like the Kolmogorov-Smirnov, are not applicable in Gibbs models due to the spatial dependence among events. Remember, yung mga estimator natin sa Kolmogorov-Smirnov involves the intensity, right? Remember, pwede kasi makakuha ka ng probability of at least one event nearby, and that will be a function of the intensity. Pero yung intensity natin dito, hindi na siya isang number lang. Okay? This is also further complicated by the need for a stable estimate of the actual intensity in the test statistic, one which is not available for Gibbs models. A workaround is to use the conditional intensity lambda at u given x in lieu of lambda at u and perform a Monte Carlo goodness of fit test. Another one is the very ubiquitous K function. The K function is essentially an expected number of events within the distance h of an arbitrary event normed by the intensity. Empirically, this is computed as K hat equals the area of the region over n squared times a counter. So just look at summation I not equal to j, I sub h, d of ij. Ano lang yan? Yung I dyan, 1 or 0 lang yan. So 1 yan kapag mas yung ith and jth event ay malapit sa isa't isa by at most h. So yung double sum na yan, binibilang lang niya kung ilan yung within that particular distance. Tapos yung w sub ij, it's actually an edge correction technique. So imagine kung nasa gilid ka na ng lugar, halimbawa UP Diliman campus, nandoon ka na sa may NICS, na siguro yung area na malapit na sa Cruz na Ligas, for example. So wala na yung Cruz na Ligas sa UP campus na na mapa at hindi mo na siya interest. So think of a point near Cruz na Ligas pero nasa UP pa, tapos draw a circle. Yung bahagi ng circle na nasa loob ng UP campus at hindi sakop yung Cruz na Ligas, over the circumference of that circle, that is Wij. Okay? So it's actually a conditional distribution then. Right? Come to think of it. So syempre, pag nasa interior ka ng study region, Wij is equal to 1 lang. Diba? Kasi fully interior ka eh. So put an imaginary circle around that random point, and then what's the proportion of the circumference which is in R? And the entire circumference itself. Okay. So under inhibition, for example, in the Strauss process, and given the interaction range R, the statistic S, which is equal to the number of pairs of events at most R units apart, relates to the K function as follows. So S is approximately n times n minus 1 over 2 times the study region's area times the K function at that particular point, ignoring the edge effects. Intuitively, and as technically shown by Baddeley and Turner in 2000, the pair n of x and s are sufficient statistics. Malaman mo lang tong dalawang ito kasi, no? Hagip mo na kung ano yung magiging intensity, no? Under a homogeneous boson. So sufficient stat yung dalawang yan. Making n of x and k hat also jointly sufficient kasi k will now be a function of a sufficient stat. Hindi nga lang sila minimally sufficient. Okay. So pag na-build na yung K function, the upper and lower simulation envelopes of the K function are constructed from M independent simulation of N events in W. So for each, let's say, actually, ito ay ginagawa for every H. No? Imagine nyo, let's say, you have H equals 1. And then you have until H equals 100. Tapos one step, no? One whole number step. So for each H, mag-simulate ka M, independent, na tapos kukompute mo yung K function for those. Hahanapin mo yung pinakamalaki at pinakamaliit. Tapos magbibuild yan ng trace, di ba? So makakabuo ka ng envelope. The significance of the K function trace is assessed by the probability that K hat is larger than the upper edge of the envelope equals to the probability that K hat is less than the lower edge of the envelope, and this is 1 over M plus 1. Siyempre, negligible na halos yung probability kapag you have very large M, and the level of significance approach does not matter anymore kasi it will turn out significant anyway. So you just look at the envelope as capturing the K function trace. And then there's also residual analysis. No? Yung pwedeng gawin ay inverse lambda residual. In this residual measure, each event location in the region B is weighted by the reciprocal of the fitted conditional intensity at that particular point. So the measure is presented as summation over I of the reciprocal of the conditional intensity minus the size of the study region. The summand in the minuend is called the exponential energy mark. No, for those with application in physics, meron silang special term, exponential energy mark. In fact, sa R, pwede mong palabasin to via the EEM. No? The residuals are computed such that the expected total exponential energy weight of the events in B should be equal to the area of B. The other one is Pearson residuals. For Pearson residuals, each data point is weighted by the reciprocal of the square root of its fitted conditional density. So, dinidivide siya ng square root kasi ito assurance natin na magkakaroon ng constancy invariance. Actually, hindi naman talaga lalabas na constant yung variance, pero homogeneous naman. So, generally speaking, behaving well. Kasi hindi naman talaga siya magpa-flat na constant yung variance. Homogeneity, magkakaroon lang siya ng homogeneity. Okay, and then for plots, now we can have residual plots against the northing coordinate alone, the easting coordinate alone, or in a contour plot overlaid on the study region. The K function for residual, eto inisip ko na lang to. The K function was for the residuals may be built. Well-fitted models will result of a residual K function to be contained within its simulation envelopes. And then we can also compute for leverage and influence. So consider lambda at U given X as E to the theta prime Z, whose elements are earlier defined. So yung theta, yun yung parameter vector natin, yung Z, yan yung mga yan yung ano yung trend surface that will matter. Is it a linear trend? Is it an exponent, a polynomial trend, etc. The leverage is the scalar valued function h hat equals theta hat at U given X, Z of U given X times the earlier Fisher information, no? Evaluated at theta hat times Z star U at X at theta hat prime, where I theta is the Fisher information matrix. So again, it depends on whether this will exist. Kasi hindi ka talaga makakapag-perform nito, no? Ito nagkakaproblema kapag masyado nang mataas yung number ng covariates sa data set, no? And then Z star U X theta hat prime is given by this. A high value of the leverage identifies point locations in the study area that are more important in establishing the conditional intensity. As to the leverage, as to influence, the influence of a point xi is the scalar value S at xi given X, which is 1 over P times Z of xi given X. Again, the Fisher information inverse, Z star xi given X theta hat. Ang kaibahan ng leverage sa influence, yung leverage kasi para nag-identify ka ng mga points, di ba? So parang kapag pag nag-estimate ako sa point na ito, no? Nakakapag-contribute ba siya sa conditional intensity kahit wala naman akong na-identify na wala naman akong let's say relevant event. Dito sa influence, yung data point itself present yan. Ang tanong is pag tinanggal ko pa tong data point na to, madidisturb yung aking model, no? Yun yung tanong. Pag tinanggal ko ba tong point na ito, madidisturb ba yung model? Okay? So ako kasi mas tinignan ko kasi lahat yung point, no? So I'm looking more of the influence over the leverage. Mas gusto kong i-assess yung influence rather than the leverage. Okay. So the rates, no? Ano yung mga theoretical consideration, and it seems na syempre I'm just running it down, pero when you implement it, ang daming trial and error kasi ang daming like very challenging yung kung merong real data no? Kapag real data siya, ang daming surprises na present, na nag-try ako mag-thin, nag-try ako mag-change ng window, nag-try ako mag-alis ng points na big chunk, etc. Okay? So just bear with me because I originally planned to model the landslides in the entire Philippines. However, nagkakaroon ako ng issue with convergence kasi ang laki ng difference ng intensities if you go central southern Philippines compared to northern Philippines. Okay? So nag-decide ako mag central southern na lang. At doon mas evident kasi yung inhibition. So landslides in the Philippines ang ating geophysical phenomenon of interest. The Philippines experiences many atmospheric and geophysical challenges like typhoons and earthquakes, making it susceptible to landslide. Ngayon, 'di ba, we are experiencing Odette, 'di ba? So parang ang merong agreement dun sa finding ko kanina kasi naka-identify ako ng corridor. So in this case, nagmamaterialize tong first sentence na to kasi meron tayong iniinda ngayon na typhoon. Our rainfall patterns, jaggedness of terrain, no? Geology, kung saan malambot ang lupa, saan matigas ang lupa, soil quality, land cover, including built-ups kasi 'di ba ang mga landslides pwede naman mangyari sa mga remote na lugar, pwede rin sila doon sa mga habitation. Pag sinabing built-ups, ito yung may mga konkreto na mga structures. Okay? And seismicity, no? yung mga earthquake events natin, make localized landslides a real and present hazard phenomenon. While landslides in Luzon are spatially clustered, landslide events appear to be spaced in the central and southern Philippines. We will work on this point pattern and fit in the Gibbs model. There are 84 events in the spatial point pattern in this part of the country around the time of the Ginsaugon landslide in Leyte. If you remember that in the news, medyo matagal na yon, di ba? Pero grabe yung tragedy ng Ginsaugon. So, ang daming, this data was gathered around that time kasi nga nagkaroon ng curiosity on how landslides are happening, no? So, since parang merong belt na na-identify, no, gusto malaman ano ba yung occurrences, rate of occurrences ng landslides, no? So data was sourced from the Department of Geodetic Engineering, UP Diliman. So looking at the right side of the screen, that is my study region. That square, no, which is looking at the central and southern Philippines. Okay, so fitting the model. The fitted model established the hardcore distance of R equals 0.00033811488. Guys, do not underestimate this number, ha? Kasi remember, ang datos dito ay Cartesian coordinate. So 120 point so many digits. So what do I have here? I have like 10 decimal places. It matters, no? Kasi yung halimbawa, one point difference, ilang daang kilometro yon, no? O baka libong kilometro pa, right? So yung 0.00338, malaking distansya yan sa totoong tingin sa mundo, no? So ang Philippines, di ba, nasa 120 to 127 lang ba? Tapos nasa 120 to 127, tapos 5 to 22. Ganun lang siya sa Cartesian coordinate na buong mundo na yung tinitingnan mo, ha. So that number, although parang ang liit in its actual form, or malaki yan sa totoong buhay. Okay? So under a flat trend, ito yung fitting the hardcore, kailangan ko kasing magkaroon ng intensity estimate para meron lang akong background. Tapos kailangan ko rin ma-establish yung hardcore distance. The R here is actually the MLE. So ito yung pinakamaliit na inter-pair, inter-event distance, no? So given the estimated R, the Strauss inhibition was postulated with several polynomial trends in the spatial coordinates to represent Z. Since no geophysical covariates are present in the dataset, only the spatial coordinates were given, model fitting was limited to the northing-easting information. So yung northing-easting, ano lang yung northing? Yung northing will be like the latitude, and then the easting will be the longitude, no? So wala akong data on, halimbawa, soil quality, kung may recent earthquake ba, ano yung population, ano yung economic activity, baka may mining, etc., etc. Wala tayong ganong information. Pero that can be added in this particular model. In Z at U, X, pwedeng dagdagan yung column para mag-accommodate ng covariates which are not the northing and easting information. So the Strauss R equals 0.00338148 with second order polynomial in spatial coordinates seem to fit best. This is supported by its AIC. Actually, the AIC here is the AIC that is measured through the maximum pseudo likelihood, no? So ang function dyan is AIC dot MPPM sa R. Okay? And the LR deviance statistics when other models are compared against it. So ang mga tinry ko is Strauss with flat trend, Strauss with linear trend, may intercept, may X at saka Y, tapos Strauss with linear trend and an XY interaction, then Strauss with XY interaction and quadratic in Y, then I had Strauss with XY and quadratic in X and Y both, Strauss with XY, an interaction and quadratic in X, and then the full quadratic, no? So yung X, Y, XY, X squared, and Y squared. Okay? So ang pinakamaliit na AIC is the polynomial, the full polynomial with the coordinate interacting. So that's negative 29.935, and you can perform the deviance test. Kasi log linear nga siya, di ba? So you can do parang sort of an ANOVA wherein you compare, let's say, the flat trend versus Strauss polynomial xy2, xy of order 2, that's the last line. This is the polynomial order 2. Okay, so you compute that with the rest, so you'll see that this is significant at 0.05 level. So may pagkakaiba talaga, no, yung fit noong other trend surfaces compared to the polynomial xy2. So dito nag-stop na dahil nung mag-attempt na ako ng cubic, hindi na ako nagkakaroon ng non-singular fissure information. So may limitation ako in that respect. Okay. So perhaps the most important output of this work is this map. No? Siguro if I were to choose one slide from this presentation and put it in an abstract, this is it. Okay. Now, the conditional intensity based on the polynomial xy2 with the hardcore constraint, no? With the hardcore constraint, the pattern in the estimated conditional intensities using the fitted Strauss plus polynom xy2 model revealed a hazard corridor that traverses the Panay Island, going to the direction of Negros, Cebu, and the Bohol Islands, then moving to central Mindanao, passing to the northern part of Zamboanga del Norte and Sur, Misamis Occidental and Oriental, Lanao del Norte and Sur, Bukidnon, Cotabato, Davao Sur, and Occidental, and a portion of South Cotabato. So itong nakita ninyo dyan na parang yung yellow, no? That path is actually the hazard corridor. And this is this is like the ultimate thing that we want to see in point pattern analysis. Given our model, we need to see pockets kung saan nagkakaroon ng hotspot. No? Dito parang may hotspot ako ng intensity. Okay? Siguro kung meron pa akong additional covariates like soil quality or seismicity, I could have found something in eastern Samar or perhaps in the northern Surigao area. Kasi meron diyang mga landslides din na substantial pero hindi sila na-capture dito sa corridor na to. Kasi baka hindi yung spatial coordinates ang nagdidikta ng intensity na yon. It could be that there are other geophysical entities, no, or factors that affected bakit may landslide sa mga lugar na yan. So curious ako doon sa Eastern Samar at saka doon sa Agusan, no? Sa the Agusan Norte, Agusan Sur. Kasi merong substantial number of landslides doon pero hindi sila na-highlight dito sa corridor na ito. Okay? So this is the CIF. This is lambda hat at u given x, right? So we make this map parang very fine, parang may grid tapos at each of the grid points we estimated lambda hat and this is what was revealed to us under this model. Okay. So for the goodness of fit, the K function generally fell within the simulation envelopes except for a portion of the trace of the lower range of scale. While it is difficult to stipulate a possible source of inadequacy, an intuitive mitigation is to incorporate covariates aside from the spatial coordinates. This may include rainfall, typhoon incidence, seismic activity, soil quality, and possibly human activities related to the environment. So maganda na sana kasi yung simulation envelope na-capture na niya yung trace, di ba? So ibig sabihin yung finifit nating hardcore model, no? Wala sana siyang nakitang digression, pero may konting nagmintis dito. So eto parang indicative siya na meron tayong kulang. Meron pa tayong kulang, no? So since na-exhaust ko na yung possibility ng spatial coordinates kasi hindi na nga ako binibigyan ng non-singular information matrix kapag puro na lang sila, siguro pa nagdagdag ako ng isang non-coordinate na data, no? I mean not the easting and the northing, like halimbawa yung rainfall, baka pumasok na yan dyan. Kasi baka nga naging very heavy yung rainfall in, let's say, Eastern Samar or in Agusan. Kaya may nagkaroon ng landslide doon. For the residual analysis, larger residuals are observed along areas in the Leyte Island and along the Dinagat Islands, Surigao del Norte, Agusan del Sur, and Surigao del Sur. The model was not able to estimate high conditional intensity in these parts of the study region compared to actual occurrence of landslide events in these areas. The Pearson residuals revealed the same observation to that of the inverse lambda. In addition, the cumulated Pearson residuals tend to be positive towards the northern direction, yet tend to be negative going south. Positive residuals also dominate towards the east of the study region. And based on that, talagang na-isolate nila yung Samar Leyte area at saka yung going down na eastern part, no, southeast part, which is actually nga the Caraga region. For the residual analysis, yung K function ng residual, the K function of the residuals revealed that the model can further be improved with the addition of covariates aside from the spatial coordinates. No additional covariates are suggested for inclusion had the trace of the residual K function fell within the simulation envelopes, indicating CSR among the residuals. This supports the observation earlier on the K function of the hardcore model. As to influence, areas with strong influence on the fitted model are portions of Antique and Iloilo, Negros Occidental, Leyte Island, Dinagat Islands, Agusan del Norte, Bukidnon, Davao Oriental, and a big portion of southern Mindanao, covering Maguindanao, Sultan Kudarat, South Cotabato, and Davao Occidental. Dropping events from these areas will remarkably alter the fitted model. So as a recap, we had the model, we established the conditional intensity, we looked at the goodness of fit, we performed the residual analysis, and then we looked at the influence. So for the model, we postulated linear and quadratic trends in addition to the straws. We found that the polynomial XY order 2 fitted best. The estimated conditional intensity revealed a hazard corridor from western central Visayas going towards central Mindanao. The K function of the hardcore model is generally good, but with suggestion to improve adequacy through addition of covariates. Larger residuals in the Eastern Visayas and Eastern Mindanao indicate that the model has underestimated intensity in these areas. Then finally, we identified major areas whose absence or deletion from the data will erode model fit. So in conclusion, the inhibition process exhibited by the landslides in central and southern Philippines was approximated by the Gibbs model using maximum pseudo likelihood. The model accommodated the polynomial trend with respect to spatial coordinates and the maximum likelihood estimated hardcore distance. Model diagnosis suggests addition of covariates to lessen large residuals and promote complete spatial randomness and residual behavior after the inhibition and spatial trends are accounted for. And that ends my talk. You can see to the left of your screen the actual S3 map of the abundance of landslides in northern Philippines and the inhibited or the sparsity of landslides in central southern Philippines. Maraming salamat po.
Thank you so much po, Prof. Kiko, for sharing your work. Napaka-interesting po ng work ni Sir Kiko on Gibbs modeling at in-apply niya po dito sa actual data sa Philippines. So I think maraming na-inspire to do this research din, no? Ituloy yung ibang
people to do this. Projects na talagang meron talagang impact. Ito very important for the environment.
Yes po. Maraming salamat po ulit, Prof. Kiko, and thank you so much. We would just like to ask the audience kung meron ba kayong questions for our speaker, si Prof. Kiko. Sige, pwede nyo pong gamitin yung ating chat or pwede po kayong mag-raise ng hand kung meron po kayong questions. Sige po, habang naghihintay tayo ng questions from the audience, may tanong lang po dito, Prof. Kiko, kung paano po na-reveal nung Gibbs model yung hazard corridor?
Okay. Yung Gibbs model kasi, imo-model niya yung conditional intensity. Diba? So may forma yung model na yon. The conditional intensity is lambda. Diba? So lambda, log lambda is equal to an exponential. Ito yung Baddeley and Turner approach. So siguro para mas concrete. Kunwari ang nabuo ko ay polynomial order 2, diba? So log of the intensity at, let's say, ano ba, at 120, 20. Yun yung coordinate, 120, 20 equals, 'di ba? So meron akong log of that, 'di ba? Kasi pag na-log na siya, linear na yung nasa kanan, right? So log of lambda equals kunwari polynomial of order 2. So meron akong intercept plus a coefficient multiplied to the northing, now which is, let's say, 20, plus a coefficient multiplied to the easting, which is 120, plus a coefficient multiplied to the product. So let's say that coefficient multiplied to 120 times 20, plus a coefficient of multiplied to the square of the northing, plus a coefficient multiplied to the square of the easting. So alam ko yung address, 120 at saka 20, di ba? Plus the hardcore, the straws. Ano yung straws? Sa straws, kailangan ng inhibition distance. So ang estimator nun, T. So let's say ang R dito is 0.00038 something, di ba? So bibilangin ko ngayon, doon sa 0.120, 20, ilan doon yung mga landslides na within 0.0003818. Tapos may coefficient din yon. So yun yung log. Tapos ia-antilog mo. Makukuha mo ngayon yung actual ay yung estimated na conditional intensity. Okay? Kaya mahalaga na na-establish yung 0.00318 something maaga pa lang. Kasi yun yung magsasabing, itong model na to, meron siyang coordinate system, may coefficient yung bawat northing, easting, and its functions, plus a coefficient multiplied to the number of points na which are within this region. So typically, kasi binibilang mo kasi yung sino yung malapit, hardcore distance ka nga, dapat mas malayo sila. So pag nakita mo yung pag pinakita yung coefficients, maisusulat kung paano arithmetically or algebraically madiderive yung lambda.
Okay, sige po. Thank you po, Prof. Kiko. Siguro one more question po. Meron pong question dito kung pwede po bang pa-explain ng rationale behind the formula for the Strauss process penalty?
Okay. Remember, kailangan mo ng inhibition parameter, which is gamma. Yung gamma palapit sa 1 o kaya palapit sa 0. So naroon yung penalty na yon, no? So parang pa-hardcore ka ng pa-hardcore o pa-CSR ka ng pa-CSR. Pero pag sumobra ka sa 1, invalid yung model. So hindi ka niya bibigyan ng estimate. So naroon yung penalty. So doon sa pag-move na yon ng gamma. Kaya mahalaga kapag nag-model, babantayan ninyo kung ano yung nilalabas na MPLE nung gamma, no? Kasi pag yan ay sumobra sa 1 kasi pwedeng mangyari, hindi yun yung penalty, no? Kailangan ma-thin, kailangan mawala yung mga points na nag-violate ng hardcore.
Okay, thank you po, Prof. Kiko. Sige, do we have more questions from our participants? Okay, kung wala na, gusto lang ulit namin pasalamatan si Prof. De Los Reyes, and bilang pasasalamat po, we are awarding this certificate of appreciation to Prof. Francisco N. De Los Reyes, our 2021 Angeles Buenaventura Professorial Chair in Statistics. So maraming salamat po, Prof. Kiko, for your excellent lecture entitled Going Hardcore, Gibbs Modeling for Inhibition Processes, given this 16th day of December 2021 via Zoom, signed by Dr. Joseph Ryan G. Lansangan, our Dean, and Dr. Imogen F. Evidente, our Director for Research.
Thank you very much.
Thank you po, Prof. Kiko. Again, we thank everyone for attending. And of course, to our speakers, Prof. Martin and Prof. Kiko, for sharing your work with us. Bigyan naman po natin sila ng virtual applause and heart reactions. Ayan po, para po ma-improve din natin ang ating next lecture series, we also welcome feedback from our participants, and pwede rin po kayo mag-request ng certificate. So yung link po ay nasa inyong screen po, at itatype na lang din po sa ating chat yung link para po masagutan natin yung feedback form and request for certificate. Since this is our last speaks for the semester and for 2021, we would also like to recognize yung ating mga participants who regularly attended our Stat Speaks events this semester. So maraming salamat po, Marty Banyaga, Mary Ruth Velasco, Rafael Jose Raviz, Jesper Bayawa, and Jocelyn Uba. So maraming salamat po for always attending our Stat Speaks events. So again, thank you po sa ating Stat Speaks speakers, and we hope to see you all again next year. So like nyo lang po yung ating Facebook page, UP School of Statistics, or subscribe to our mailing list para po maging updated tayo sa ating mga susunod na events next year. So muli, maraming salamat po and happy holidays. Thank you po.
Merry Christmas, everyone.
Sir Kiko, thank you po.
Thank you. Thank you.
Thank you din po sa lahat ng nag-attend today. Sana po makita namin kayo ulit next year.
Oo nga. Tapos na ba? Wala nang professorial chair. Last na to.
Sir, ito na yung last. Kaya yun. Maraming salamat, sir. Very interesting po. Pwede po natin gawing project natin, isa sa mga research projects. Gawa tayo ng project team.
Maganda siya kasi ang daming pwedeng ma-explore. Ang challenge ko yung map. Ang hirap maghanap ng data. So dito, naghagilap ako ng mas recent sana. Kaso lang walang mai-provide si Geodetic Engineering sa akin. Pin-forward nila ako sa NAMRIA. Kaso lang may bayad. May bayad na pag bumili ka ng mga special processing. Si DOST hindi ko na try pero parang nanghinaan ako ng loob nun sa NAMRIA, may bayad. Dami sanang pwedeng gawin.
O sige sir, tingnan natin, pag-isipan po natin.
Actually, hindi kailangan inhibition, pwedeng clustering naman, the other end of the spectrum. Ibang technique naman. Pero yun naman, pag halimbawa magkakapit-kapit, halimbawa yung mga mga projects ng government, I don't know, hanap tayo kung ano.
Yeah. Sige pa sir, sige, tingnan natin. Uy, Xavier, thank you
Yeah, thank you.
Thank you rin po. Thank you.
Iyan.
Yung mga si Zar, si Gian, at saka yung mga perfect attendance po nandito pa. Si Tor Velasco po at saka si Jesper po. Salamat po sa pag-attend.
Thank you po.
Bye.
Happy holidays po.
Happy holidays. Madilim na sa labas.
Oo nga.
Nasa office ako ngayon Nasa admission ako ngayon
Sir, nandiyan pa kayo?
Yes, dito ako Kasi ang dami ko nga speaking engagement kanina, umaga pa lang. Tapos
Umaga pa lang nga
pa ako nung awarding ng Gawad Pangulo.
Congratulations pala, sir.
Thank you.
Congratulations.
Nakakatuwa yun.
Congrats po.
Kagabi ko nalaman Kagabi dumating yung Kagabi lang namin nalaman. Tapos pagising namin kaninang umaga, nagbabatian.
I see. Kaya pala parang ngayon nyo lang nalaman din.
Kaya nung 9:30 nakaantay na ako, 10 o'clock nag-start. Tapos kasi under College of Engineering nakalagay yung project Pero originally, initiative lang siya ng volunteer. Kaming 6 plus 4 sa engineering. Pero dahil sa engineering, parang yung organization nila, pag gumawa ka nito, kailangan ipasok mo sa parang research agenda ng college. Since hindi naman tayo ganon, so kami, binuo yung team, no? Merong may appointment yan So yun, tapos it started lang as a forecasting thing for rice and then basic commodities na minomonitor ng DA. Tapos nag-roll up na siya into DTI monitored products. Tapos ang trabaho ng stat people, forecasting, spatial modeling, pero si Department of Operations Research, yung transportation model na in the light of the lockdowns. Kasi meron kaming mapa kung saan naroon yung mga lockdowns. So saan dadaan yung delivery for the ayuda. Yun yung ultimate. So parang meron yang may dashboard na nabuo. So halimbawa, kukunin mo yung sardinas dito sa Batangas, tapos dadalhin mo sa Nueva Ecija, tapos may mga lockdowns in between. Saan siya dadaan? So DPWH map yung hawak namin na inoptimize. So yun, yung dashboard na yun, nasa DTI na. Ginagamit na nila sa DTI. Yun yung pamana namin sa kanila.
Hindi pa kayo uuwi?
Uwi na.
Sige.
I'm just taking my water.
Okay, thank you, sir.
Bye.
Thank you po.
Ingat kayo. See you on Monday
Yes
sa party
po.
natin. Okay.
Sumabay sa Office of Admission Party. Ano ba yan?
Sir, dapat dumaan.
Last year.
Ano ba? Face-to-face ba? Face-to-face ba tayo?
Hindi
Hindi po.
Kayo ba face-to-face, sir?
Face-to-face
Wow.
kami. Diyan sa may parking lot ng baba, sa baba.
Kami na lang po join doon.
Lilipat na lang. Bakit meron ba
Last year, sir.
Join doon.
May mga nasa
Last
start
year,
sa Monday.
sabay din, di ba? Meron din po.
Ah,
Yan si
okay.
Gian po.